Alrighty, this is our last lesson in our linear equations unit, systems of linear equations, systems of linear inequalities, graphing them, solving them, all that good stuff. This is going to be developing and solving systems of inequalities through looking at word problems, and then writing those inequalities based on the given information, and then eventually graphing those inequalities. For the sake of time, I'm going to skip this do now, just because the last video took a long time. I just want to make sure, don't forget, when a total needs to be at most, this at most means that's the most amount I can make, and I want to go from the most down lower. So actually the inequality symbol that we would use would be less than, or maybe the less than or equal to sign, and I'll draw that a little bit nicer, right? Less than or equal to sign would actually be this, right? That is at most. At least, which I might as well do since I'm already on the presenter here, that means that's the smallest amount that I want, and I could go at least or higher. So at least is actually going to be greater than or equal to, or just my regular greater than symbol. It's really important because these are used a lot in word problems. Now, I'm going to skip straight ahead to what looks like a regions type problem instead. I'm going to skip straight ahead to this one over here. So don't forget, when we're setting up systems of equations or systems of inequalities, we have our two different types of problems that frequently come up. Those are the value and amount problems, where you have an amount of something, just straight up the number of kids and adults, the number of quarters and dimes, and then the value, which is some multiplier that goes with those. Your other type of question is your two scenario question, which is like those ones we saw in the previous videos where you're using the same two things in two different situations. I have a sprayer and a generator. I'm using the sprayer and generator each for 6 hours in this first job, and then 4 hours of the sprayer, 8 hours of the generator in the second job. And you have two different totals, and you can figure it out from there. So just keeping those two different types of questions in mind. Not absolutely everything is one of those, but a lot of questions do end up being one of those two types. All right, let's get to it. Edith babysits for X hours a week after school at a job that pays $4 an hour. So babysitting is X. So I'm going to say let X equal, why is that two lines? Let X equal number of hours babysitting. And she has accepted a job that pays $8 an hour for a library assistant working Y hours a week. So now I'm going to say let Y equal hours working at the library. She will work both jobs. She's able to work no more than 15 total hours a week due to school commitments. Edith wants to earn at least $80 a week working a combination of both jobs. And now it just says write a system of inequalities that can be used to represent the situation. This one is going to be a value amount. I'm not using the two things two different times. It's not a two scenario. I have an amount of hours per week and a value that's using those multipliers, right? 8 times Y, 4 times X, that'll get me that $80. So scenario one, oh wait, it's not scenario. This is value and amount. I'm going to say my amount is just the straight up, right? Like straight up, nothing added. So the amount is my 15 hours per week. That's going to be equal to the number of hours she spends babysitting and the number of hours she's at the library. Then we have the value, and that's with the multipliers. And the multipliers are, well, it's first of all, $80 is the value, $80, and that's going to be equal to, it was $4 an hour babysitting, so it's 4x, and $8 an hour as a library assistant, so 8y. Now, this is not 100% correct because it says write a system of inequalities. Using value and amount, we've got a system of equations, but they want a system of inequalities. And now we need to look at this. They even italicized the words for us, kind of highlighted it. She's able to work no more than 15 hours a week. And she wants to earn at least 80 hours a week. Now, there's one thing over here, to follow our at most, at least symbols, that really needs my variables to be on the left and my total to be on the right. I wrote these with the total on the right. So it's okay, I'm just gonna flip-flop everything. I'll say x plus y, stop that, plus y equals 15. And again, down over here, I'll do 4x plus 8y equals 80. All I'm doing is just, and maybe I'll write both of these together, right? Let's get rid of that. Move down here just so I see them. Okay, cool. That's just to get the variables on the left so I can follow my signs for at most and at least. Now, the amount of time that she works over here can be no more than 15 hours a week. So the amount of time she works no more than has to be less than or equal to. Let's make this a nice symbol. I think I can do that with insert symbol. And, oh yikes, let me just do an equation. I think if I do an equation and I type less than or equal to, oh, that's so nice. So x plus y is less than or equal to 15. And then over here, she wants to earn at least $80 a week. So here, the $4 per hour of babysitting, $8 per hour of in the library, that should be at least $80. So this should be greater than or equal to 80, not just equal to. So I'm going to say greater than or equal to 80. Greater than or equal to 80. This is the system that they want. Now notice they don't want you to solve the system, they just want you to write it. And that's because when you have a system of inequalities, there's infinite number of answers, right? You cannot solve for a single thing. You can find answers that work, you can find amounts of times that work out for these, but you cannot fully solve it. And to show that just one more time, because it's been a while since we've been doing any kind of graphing, I'm going to come over to the calculator. Let me copy these down. So we've got x plus y less than or equal to 15, and 4x plus 8y greater than or equal to 80. Now, Mr. Patillo showed a way to get the TI Inspire calculator on either a computer or a tablet, but you can't get it on a regular phone, iPhone or Android. So what I'm going to show you really quick is another thing that you can use. This app is called Desmos. It is free to use on the App Store or the Google Play Store, and it will graph things for you. So we can go ahead and just graph it. When you open the app, it should just go straight to this blank page, and I can just type it in exactly as I see there. So I'll type in x plus y is less than or equal to 15, and it graphs it. It's a little bit to the side so you can see it over there. And next I can just click down there and type in 4x plus 8y is greater than or equal to 80, and it shows it over there. And now let's not forget, once we've graphed this, there's a couple things to pay attention to. First of all, both of these are less than or equal to, greater than or equal to, so these lines are solid. They are not dotted lines. Remember, if I switch this to just less than, it makes it a dotted line, and when you're copying it on your paper, you got to make sure you're doing a dotted line. But this was less than or equal to. The next thing, this red line, is the solution for this first guy that I drew. Everything underneath here, any coordinate here, is a solution to this inequality. The blue guy is my second inequality that I wrote, and anything in here or on the solid line is a solution to this next guy, the second inequality. And the double colored in region right here is the solutions to the system of inequalities. Any point in here is a solution to the system. Now, if you're on Desmos and you're trying to graph and you want to find coordinates to graph, all you got to do is just click on a line and then click and drag. And you don't need to, like I'm moving the little cursor away from it, but you can still drag. And you just find all the points where it hits perfectly on the line, and you will graph those guys. So I would graph the point 8, 7 for this red guy. I would graph the point 7, 8. I would graph the point Geez. 6, 9. I'd graph the point 5, 10. I mean, you get it, right? Like in the calculator, it's really nice because the trace automatically clicks to each of those. Maybe there's a way to do that on Desmos, but I haven't figured it out yet. Similarly, I can click on the blue guy and then click and drag and get the coordinates of the points to plot there. The point looks like 4, 8. 4, 8. I just had it. 4, 8. Oh my goodness. There it is. The point 6, 7, it looks like. 6, 7. And you plot all those points and you can graph them on a calculator. Just showing a different way to do it in case I ask you to graph things and you don't have that TI Inspire app or a TI Inspire calculator. Alrighty. So yeah, this is kind of nice because when I have a system of inequalities, you just graph it and you look for the answer like that, right? Any of these points inside here are good. So the point 5, 9 right over there, 5, 9 would be a solution to the system of inequalities. Again, similarly, right, system of equations, you could graph and see where they hit, but we've been doing it algebraically for a while now. All right, let's get to another question because I've been chit-chatting a while now, and we got to get to the next question. Get another example in here before we close out. The real good cinema is conducting a mathematical study in its theater. There are 200 seats. Adult tickets cost $12.50 and child tickets cost $6.25. The cinema's goal is to sell at least $1,500 worth of tickets for the theater. Now, is this a to scenario or a value and amount type of question? And what I'm seeing is I have an amount of seats and a value of the cost. This is a value amount question. Let's let A, why is it doing that again? Let A equal the number of adult tickets, and let C equal the number of child tickets. Let X, I wanted it to be C for children. And now I can say, all right, well, my amount is 200 seats. And that's equal to always just A plus C, right? Your amount is always just the amount and the two variables by themselves. And then your value is going to be 1,500 is equal to $12.50 times the number of adults, right? That's my multiplier, $12.50 for an adult ticket, plus $6.25 child, $6.25 for a child ticket. This one says to write a system of linear inequalities again that can be used to find the possible combinations of adult tickets X and child tickets Y. Oops, I guess I should have been doing X for adult and Y for child. Let's just fix that really quick. X for adult, Y for child, X for adult, Y for child. Again, to make this inequality stuff make sense, I'll flippy floppy. I'll go X plus Y equals 200 and 1250 X plus 625 Y equals 1500. And now let's see. This is the number of children or adults and children in the theater, and I have 200 seats in the theater. Well, the number of people in the theater could be exactly 200, or really, could the number of people in the theater be more than 200 or less than 200 if that's the total number of seats I have? And clearly, it's got to be less than or equal to 200 people in the theater, right? I can't have more people in the theater than I have seats, so the number of people in the theater should be less than or equal to the number of seats. And let's jump on to this next one. Now, the cinema's goal is to sell, we missed that the first time, at least $1,500 so worth of tickets. So here's the amount of money for an adult ticket, the amount of money for a child ticket. This is the amount of money that we make from selling. I want this amount of money selling to adults and children to be at least $1,500. So this has got to be at least, I want it to be greater than or equal to that $1,500. Now again, they just said write a system of linear inequalities that would be able to solve it. This is the system right here. I'm not even going to bother graphing it on the Desmos app because these numbers are so huge, it's going to be kind of like way off the screen. It'll be hard to find. Let's do one last example just to get to it. And hopefully this will be a 2 scenario. Does not look like it's a 2 scenario. This looks like another value and amount. That's okay. All right, final example. An online electronics store must sell at least $2,500 worth of printers and computers per day. This is my value. That's the value of money I want to sell for printers and computers. Each printer costs $50. Each computer costs $500. The store can ship a maximum of 15 items per day. This is my amount. There's no value associated, not money. There it is. Write a system of inequalities again to represent this situation. So I'm going to let P equal number of printers. Let C equal number of computers. My amount is just going to be 15. You know what? Let's not do this. Equals 15. And I'm going to have the number of printers plus the number of computers should be a maximum of 15 items per day. And then my value equals $2,500 in total. I'm just going to take 50 times my printers plus 500 times my computers to get me my value over there. Now, it says the store can ship a maximum of 15 items per day. So the number of printers and computers that I ship per day is a maximum of 15. So instead of equal, I got to switch this to, if 15 is the maximum, these two, my printers and computers shipped together, need to be less than or equal to 15. And let me use the insert just so that the symbol looks nice. Less than or equal to 15. But the store must sell at least, there's those words coming again, 2,500. So the amount of money that I make, the $50 per printer and $500 per computer, should be at least 2,500. This has got to be greater than or equal to, right? I'm okay with being 2,500, but I could be greater than the amount of money I sell from these. Again, I'm not going to graph these. We already saw that little mini Desmos tutorial. But yeah, that was 3 examples of setting up systems of inequalities, and that's usually enough. Sometimes they might ask you to graph it, but we saw how to do that on Desmos, and we've seen how to do that in previous lessons, graphing systems. So I think that's the end of this unit. We're going to be moving on to functions really soon. So, get prepared for that.